for sending it through. We're going to go to another question now. We're running very much out of time. So let's see if you can squeeze this one quickly. It's a very short question that is also based on Euclidean geometry. It's asking you to prove something. So let's see what we can do with it. Right. So the question reads as follows. It's got a very beautiful circle here. Okay. There's a circle, which I love. I love circles, right? I love circles, guys. When I see a circle, I get excited because it means there's geometry lying on the horizon. Okay. So we've got a circle and we've got something that is called a tangent. So there's a tangent here somewhere, right? Okay. Okay, and then these people have a line that goes to the center and that goes again to somewhere else and that goes to somewhere else. I'm a semi-pro now. Can draw this thing without any problems. There's exactly what we're dealing with here. Right, let me just use my pen to actually fix this part. Right, okay, cool. So we've got this one, which is O here. We've got a value X here, and then there's O1 and O2. Okay. There's T here, there's S here, there's M here. Apparently, the examiner is claiming that MT, not that MT, but this one, is equal to MP, right? Okay, cool. And there's P1 and P2. They have T1, 2, and 3, right? Okay, this is a question that comes from Tsepiso Lekwe Khumuto. Thank you very much for sending it through. It reads as follows. It says in the diagram, O is the center of the circle, right? Like I said, once they say center, you know, all the theorems related to the center apply. Very important. Okay. And not all, but some of them, right? ST is a tangent to the circle. So ST is a tangent. Those tangent theorems might apply as well. And M and P are points on a circle such that TM equals to MP. So two lines are equal. Two chords, in this case, happen to be equal. And we are told that O1 is equal to X. The question is the following, right? We have to prove, okay, prove that angle STM, right, STM is equals to a quarter of X, right? I hope this is visible. Let's actually move it a bit more to the right so that you guys can see it. All right, I hope this is visible. So STM equals to a quarter of X. That's exactly what we actually have to prove in this case. So this is the typical non-numerical question that you might get in the exam that involves Euclidean geometry. My advice, let's try to find all the angles just for the fun of it. You'll see the one we're looking for is going to definitely come out. So I'm going to do all I can to find all the angles in this drawing and help you, because I know geometry is always a challenge, and I hope this is going to help you in terms of understanding how do you actually work with them. If we had more time, we will do a detailed analysis. It's always love letter versus the drawing. So as far as the love letter is concerned, I've got the O as the center. It means something to me. I need to do analysis for that and then try to find anything else that is unknown based on what was informed, what I was told about this particular question. So beautiful stuff. Right. So let's see what we can do on this one. We've got a tangent. So if that is the tangent, what damage can we do here? Let's just try to do that, because that is very, very important. And it's the analysis that I'm referring to when I say you need to do analysis. So the theorems that are related to the tangent, right, are 4 in total. Ugly circles, the cyclic quads, and not really, but the centers are 4, cyclic quads are 2, tangents is actually only 1. This one says tangents drawn from the same point are equal. This one says tan chord theorem. This one says a tangent is perpendicular to a radius, right? Okay, and then the ones about cyclic quads, you know, a cyclic quad must have 4 sides, and then the one says exterior angle equals to interior opposite angle, the other one says opposite sides and up to 180 degrees. So we are actually sitting with that, and we're very excited to see that. As far as centers are concerned, we know that a line from the center will bisect a chord if it's perpendicular to the chord. We know the angle at center is 2 times angle at circumference. We also know that a diameter is going to subtend a 90-degree angle. And lastly, we know that angles on the same segment are actually equal to each other. This is a very important analysis, which is very, very basic and straight to the point. Now, if I look at the diagram, there is clearly no cyclic quad there, so these guys are going to die. There is clearly no 2 tangents, so this guy is going to die. Angles on the same segment, I don't have that. This is going to be dying. There is no diameter. This is going to die. So there is no line from center perpendicular to, so you are actually killing all the irrelevant theorems that are not going to apply in this particular question, and everything else will work out very beautifully. No complications at all. So I hope this is making sense. So what is important could only be, not that it is, it could be this guy here and these two guys here. So those are the theorems that are going to take me home as far as trying to find a solution to this. So I'm going to start with this one. Angle at center is 2 times angle at the circumference. So I want to find O1 here, right? I want to find O1 because O1 will give me this angle M here that I'm looking for. So how does my argument go? My argument starts by saying the following. Remember, we've got statements and reasons. So on the left-hand side, they give you a booklet with statements here, and you guys are plotting or you're putting reasons here, right? So I'm going to say angle O2 plus angle O1 is 360 degrees. This is because of the fact that there are angles around a point, or you can say a revolution, right? Angles around the point add up to 360 degrees. That means angle O1. That means angle O1 is equals to 360 degrees minus x. Right, I'm happy with that. Then after that, I now need to find M. I'm going to find M. M is the angle at center, has a relationship with O1 via angle at center is twice angle at circumference. So I'm going to say angle at center, angle O1 is 2 times angle at circumference. So it's 2 times angle M1. So angle at center equals to 2 times angle at circumference, which makes a very important argument because now I'm going to have 360 minus x equals to 2 times angle M, which makes angle M to be exactly, if you divide both sides by 2, you end up with a value of angle M that is very nice. It says here angle M equals to 180 degrees minus half of x, right? Minus half of x, which means this angle is 180 minus half x. Now I'm going to find these two, T2 and P1 are actually equal because the triangle we're dealing with is an isosceles triangle. So I'm going to say, but angle T2 is equals to angle P1 because those are angles that are opposite equal sides, right? Therefore, and we know that angle T2 plus angle P1 plus angle M is 180 degrees. These are angles of a triangle, or interior angles of a triangle, right? I'm out of time, so I'm actually trying to rush this through so that you guys can see what is going on. So I'm going to say, I'm going to call these in terms of P2 because, in terms of P1 because they are the same. So 2 times angle P1 plus 180 minus half x is 180, which makes angle P1 to be equal to a quarter of x. Why? Because 180 will cancel 180. If you take to the right hand side half and you actually divide both sides by 2, you're going to get a quarter of x, right? So I'm getting a quarter of x. If I go back here and I put that this angle is a quarter of x, and if you look closely, this is actually equal to that via the Tenfold theorem, right? So I'm going to say angle T1 equals to angle P1, which makes it also to be a quarter of x, and this is because of the Tenfold theorem, which means then I have succeeded to proving that STM, right? STM. Therefore, STM is equal to a quarter of x, and this is because the whole story of the Tenfold theorem is actually what we are looking at here. Very exciting content indeed. I hope you guys got to understand what you had to do in terms of working with these questions. Very nice questions that you sent to me. Thank you very much. A big shout out goes out to Liberty. Remember, guys, all of you who are accountants, the accountant is coming immediately after this particular session. So don't go anywhere. From me and the mathematics crew, a big shout out to the technical team. Until we meet again next time.